Hello everyone. Today I wanted to go over the latest development and a new feature that's been added to the STELCOR drilled in displacement micropile. But I thought I should start with going over the 7 essential elements of a drilled in displacement micropile. We are the inventor and manufacturer of STELCOR, as most here would know, and those that have successfully used our product, thank you for it. And we thought it would be a good idea to go over the details of each of these features. So there's, as I've said, 7 essential elements of a drilled displacement micropile. The first one being the steel shaft. The central shaft in our designs are to carry the entire design load of the pile from the tip to the top. So there's an unbroken shaft carrying the load. The second feature is the displacement head that goes to the tip of the pile. The displacement head moves the soil outward to provide an annulus around the shaft for the grout to fill. The third feature is a deformation structure. The deformation structure is there to create irregularity or a groove in the soil, increasing your friction coefficient or your grabbing ability. So think of it, if you look at a diagram, see we have one here somewhere. No, it disappeared. All right, well, we'll just go with it. The deformation structure makes an irregularity in the soil so that it grips the soil, much like a screw, the difference between a nail and a screw, right? That's the concept behind it. The fourth is the reverse auger. So we run a reverse auger from the tip of the pile to the top to ensure that there's complete grout coverage on the entire length of the pile. So as the pile is driving down or turning into the soil, the reverse auger is moving grout through the annulus simultaneously as the pile is being installed and into the deformation. The fifth element is the reinforcing steel. So rather than having a smooth shaft to drive the load from the soil through the grout into the steel, we include the reverse auger. We structurally weld the reverse auger to carry the load so that there's no slippage of the grout between the grout and the steel shaft. Very much like if you think of the world of rebar, you wouldn't design a project with a smooth bar. You would use a reinforcing bar with ribs on it, right? Same idea. And the sixth element is the grout ports. Somehow ports dropped off here. I'm not sure what happened there. So we have grout ports, as you can see, along the entire length of the pile. And the reason for that is if there were any crowding of the shaft at any point, the pile is not compromised for the entire length because the grout can move from the outside annulus into a grout port and back out in a lower section. So it would be very localized if it were ever to happen, right? So that's what those grout ports along the entire length are for. The seventh feature that we're introducing today is this patented BarrelForm, which is it was designed to reorganize the structure of the soil to hold it in position better in certain soils. So if you're going to a certain depth and there's a concern about soil collapsing, this barrel form is holding the soil in position long enough, much like a potter would hold the clay until it's in a position that he wants it to stay, right? So it's a reforming of the soil. And it provides a smoother installation. That's a point I wanted to come to for our installers, if there's any in the audience, is it makes for a smoother installation at a greater depth. And you're going to ask if we've done a job with it. So we've actually done several. This one in particular is of note. It was in a paper mill in Duluth, and we installed piles to 103 feet, I believe. It should be in the notes here. So the 100-foot piles, looks like they went from 100 to 106 feet, and those piles were tested to 200 tons in compression with a relatively trouble-free installation in some sloughy soils. So then we did a 35-foot pile in tension to 75 tons in the same project. So I would just say in your designs of drilled-in displacement micropile, just remember 7. You have 7 essential basic elements to an effective design, and sorry. So I think that concludes my presentation on this this feature that we've added to STELCOR. And I don't know if there's anyone in the audience that has a question. I think I have a few minutes left, do I? 2?
Yep. You're good.
Okay, I'm good. Okay.
We're a potential installer, so I'm just wondering what kind of soils are ideal for this system? Sands, clays, blow count, like how dense can we do this?
Sure.
You're using a rotary drive, like a helical system, right, on an excavator. So I think the biggest you get, 300,000 foot-pounds, 400,000 is kind of what I've seen and used. So,
yeah.
And second question, follow-up, can you do this on a batter safely?
A batter, yes. So you're thinking of like a tieback?
No, just to pick up lateral.
Just a slight batter, 15, 20 degrees, whatever. Yeah. Yeah, there's no problem with that. Yep. Yeah, because it is being, so the whole system, the whole grouting system is mechanical, right? So there's no pressure grouting in the system. So it's very predictable and it's predictable and repeatable. So because you're physically displacing the soil, simultaneously filling that void as the pile is going down. But your first question, how big? What kind of soil? So we've done it in every kind of soil. Did a job in South Texas. It went from clay to clay sand mixed to sand, and we had a STELCOR 1600 installed to 40 feet in sand clay mix and tested it to a tension load of 654 kips. Yeah. Does that answer it? Or yeah.
Any other questions? Anybody?
I might have asked you this before, Ben, but have you exhumed any of these yet with the barrel form to see how they compare with the original displacement head?
I have not exhumed a barrel form. We only know from the installation performance how well it works. Yeah. Yeah. We'll do that for you, though. Just going back to the soil types. So we will know if you send us a project or soil borings, we'll know whether it's a good job for it, and we'll tell you if it's not. Because if it's too dense for us to get good penetration, or there's a lot of rock or something, but we haven't really turned down too many yet. Some of the contractors are actually finding it efficient when the soil is too dense to pre-drill, and they're still saving money over other methods. So they do a pilot hole that's just barely smaller than the final design and run it in, and we test it. Any other questions? Oh, we got one back here. It's kind of dark.
So is the purpose of the grout ports to fill the interior of the pile during installation?
The purpose of the ports over the entire length is so that so the center is being filled during the installation, but the reason I have them for the over the entire length is so if there was a pinch at some point where you may have a running vein or something that pinched it, it's not sealing off the access for the grout to get to the bottom of the pile. So if it pinched at 20 feet and it was a 70-foot pile, there would just be a little pinch at 20 feet, but it's not going to affect the overall pile performance, because the grout can go inside and come back out and finish its project, right? And so, with this design, a pinch is not really that big of a deal if it does happen, because the central shaft is designed to carry the entire load, regardless of the grout on the outside. So the grout on the outside is a geotechnical situation, right?
Thank you.
Anyone else? That's it? All right. Good.